In this video, we are going to discuss about the flip-flops. So on completion of this flip-flops, the students will be able to explain the SR match, explain the universal gates and the gates under the universal gates. So in this flip-flops, there are different types of the flip-flops. First one is the SR flip-flop. So in the SR flip-flop, when we are giving the input as the 0, it is given to the NAND gate, and 1 is also given to the NAND gate, and when 0 is given, it connects to the Q bar, and when 1 is given, it connects to the Q value as 1. So when it is 1, it is reset. So when both the inputs or any one of the inputs is 1, then it is 1, and if both the inputs are 1, it is 0. And in this flip flop, you can see the value as in S bar, that is SR latch you have seen in the previous row table. So in this S bar R bar, the first value is when the input is 0 0, there is no value. 0 1 means it is set, and 1 1 means 1 0, that is hold position. When in this value X and Y, if one of the input or any one of the inputs is 0, then we call it as NAND as 1, and otherwise it is 0. So these inputs can be set to the resolution set, and it can be reset or it can be holded. So when it changes from 0 to 1, it is reset, and when it changes from 1 to 0, it is set. And when it changes from 1 to 0, and the two inputs are 1 1, it is hold position. So in this flip-flop, you can see when 1 and 0, 0 and 1 is given as an input, the Q bar is 1 and 0, that is set position. When the inputs 1 and 0 is given, the Q bar is 0 and reset position. And when the inputs 1 and 1 is given, the Q and Q bar is 1 0, that is in hold position. So these flip-flops can be changed when the Q and Q bar is allowed and 1 1 is disallowed. So flip-flops can be changed from when there is 0 0, there is no change, and when it is a Q equal to 0, it is a reset state, and Q is equal to 1, it is a set state, and other it is undefined. So these flip-flops, these latches are transparent, and the inputs can be seen in the outputs immediately. This causes the synchronization problems, and this uses the latches to create the flip-flops that can respond only on specific types. So these are the types: RS flip-flop and D flip-flops. So under this, you can see the master stage of configuration. So this SR flip-flop will be used as an inverter, so that this connection will be given from the clock pulse to other clock pulse here. So you can see the clock variables. So when these inputs are 0 0, it is store, and 0 1 means reset, 1 0 means set, and 1 1 means disallowed. So when V is equal to 1, master is enabled and it stores the new data. Slave stores the old data. When C equal to 0, master state passes the enabled state master not to sensitive to send you the new data. So you can see here the flip-flops. So the characteristic table is Q of t means it is a present state, and the Q of t plus 1 is the next state. So when it is 0 0, there is no change. 0 1 means it is reset, and 1 0 means set, and 1 1 means invalid. So here 0 0 means it is set, and 1 1 is reset. And here the timing parameters. So quiz questions on the flip-flops, difference between the latches and the registers. Thank you.